Hey everybody, this problem is pretty cool. It lets us use theorems that we know to find out exactly how many solutions we have in an interval. So let's get on to it. First part of the problem asks us to show that there is a solution to f of x equals 0 in this interval. So the solution uses the intermediate value theorem. And remember that the intermediate value theorem says that if f of x is greater than 0 somewhere and less than 0 somewhere else, then there is a place where it equals 0. So let's just find some easy numbers. F of 0 is 0 plus 0 plus 0 plus 2. And that is greater than 0. Now let me find a place where f of x is less than 0. Let me plug in negative pi over 2. Because that'll make sine of x easy. So that equals negative pi plus sine of negative pi over 2, which is negative 1, plus negative pi cubed, negative pi over 2 cubed, plus 2. So this is approximately equal to, so if I set pi equal to 3, this is like minus 3, minus 1, minus something close to 10, plus 2, but it's something that is less than 0. So yeah, so this implies that f of x is 0 somewhere between negative pi over 2 and 0. Okay. Next step of the problem is asking us to state the mean value theorem. The mean value theorem says that for any interval and any function, then the slope of the secant line equals the slope of the tangent line of the function at some point. Okay. And there are some technical requirements on this intuitive proposition. The technical requirement is that f is continuous on a to b, closed interval, and differentiable on the open interval. That's the mean value theorem. There's another theorem that the question refers to called Rau's theorem. Rau's theorem is the mean value theorem when f of b equals f of a. And it says that there's a place where the slope equals 0. Mean value theorem, that's the only theorem we actually need. So let's use the mean value theorem to show that there's one solution. Here we showed that there's at least one solution. Now we're going to show that there is one solution. So suppose that there are two solutions. Suppose that there are two. And let's call those solutions C1 and C2. So what am I doing here? I'm doing a proof by contradiction. So I'm going to assume something that is absurd, that there are two solutions. And then I'm going to show that pigs fly. But pigs don't fly. So that there's just one solution. Okay, suppose that there are two solutions. Then, what does that mean exactly? That means that f of C1 equals f of C2, which equals 0. That's what it means for C1 and C2 to be solutions to f of x equals 0. So that is our assumption. Let's see if our assumption leads to a contradiction. So this implies that f of C1 minus f of C2 over C1 minus C2 is equal to f prime of some c for c inside C1, C2. And by this assumption, this thing over here is 0. And I guess I really need to assume that there are two solutions that are not equal to each other. Okay. So this tells me that the slope must be 0 somewhere in this interval. Okay, now we're almost there. Let's show that f prime c is not 0 anywhere in this interval. That would be a contradiction to this. Okay, so f prime c, let's compute it. It equals 2 plus cosine c plus 3c squared now this thing is positive. This thing is between -1 and 1. And this thing is 2. So 2 plus something that is between -1 and 1 and something that is greater than 0, that is strictly greater than actually 1, but it's, in particular, it's greater than 0. So f of prime c is 0 somewhere in here, but f prime c is greater than 0. That can't happen. It can't be both equal to 0 and greater than 0. So that means contradiction. It's a contradiction to what? That there are two solutions, that there are two different solutions in this interval. So this implies that there is just one solution. Okay, there must only be one solution.